I'm going to show you how to use an inexpensive Click PLC from Automation Direct as a field I/O device for a CODESYS soft PLC. So right now I am in the Click PLC programming software and I need to start a new project. And I'll just start an empty project, and this PLC that I'm using is this PLC. It's a 2-slot PLC with an Ethernet port. You have to use a PLC that has an Ethernet port if you plan on using Ethernet IP. If you're using this PLC, it has the 2 option slots, but it doesn't have an Ethernet port, so that won't work. This PLC has the Ethernet port and the 2 I/O modules plus an RS-485. It has an SD slot, and there's also a wireless adapter in this PLC. This one costs about twice as much as the one that I'm using, but it has some additional options. There's also a single slot version of this. There's also some of the not the Click Plus, but the standard Click PLCs that have an Ethernet port. I believe those can be used for Ethernet IP as well, but they don't have the onboard I/O slots. You have to use the external I/O modules. But this is the PLC that I'm using. I'll say OK, and I'm going to disable the password requirement for this project just because it makes things easier, and I don't need security for what I'm doing here on the bench. So now we've got our project created. I need to set up the PLC. I'll go to System Configuration, and I'm using this power supply. And in slot 1, I have this combination I/O module with relay outputs. And in slot 2, I have the same combination I/O module. And then the first external slot, I have an additional I/O module, and that is this 8-output relay module. So now I've got the PLC set up. I can say OK. And then I'm going to need to set up the COM port. So I'll go to COM port setup and need to set up the Ethernet port. That is port number 1. So that's the Ethernet. It says there. Port 2 is the RS-232 port. If you're using one of the other PLCs, there's going to be additional options for wireless Bluetooth or the RS-485, but we're just going to set up the Ethernet port for Ethernet IP. And I'm going to use, I'm going to define an IP address, and that's going to be 192.168.13.10. And my subnet mask is going to be 255.255.255.0. And because I'm not connecting to the internet, I don't have to define a default gateway. But I'll go ahead and put in 192.168.13.1. And I'll leave my DNS server as 0000. Unfortunately, because of my screen resolution, I cannot see the OK button. It's off the bottom of the screen, so I'm just going to tab over. But once you've set up the IP address and the DNS server, you can just choose OK, which I'm going to do with the Enter key. And again, that's off the screen. You can't see it, but it is there. And then I'm going to say OK. And now the PLC is configured. I need to set up the Ethernet IP communication. So I'll come in here, and the first thing I'm going to do is going to check the Enable Ethernet IP adapter box. There's some different options here. You can have up to 2 connections, and there's reasons you'd want to do that if you had mixed input or output types. If you're using discrete I/O as well as analog I/O. You might want to put all of your digital inputs and outputs on one connection and all of your analog outputs on a second connection. But I'm just using digital inputs and outputs, so I'm just going to use one connection. I'm going to leave the port number at the default and the timeout at the default. So I have 2 tabs. One is my inputs and one is my outputs, and these are the inputs on the PLC and the outputs on the PLC. It gets tricky. So these are the inputs and outputs on the Click PLC. It gets tricky when we're talking about inputs and outputs. Are we talking about the remote I/O, or are we talking about the soft PLC? In this case, we're talking about inputs on the Click PLC. So the X0 through X8 and the Y0 through Y8 would be the outputs. So I'm going to leave the default as on this option. I'm going to leave that on hold, and that means if the Click PLC loses communication with the CODESYS PLC, if somebody disconnects the Ethernet cable, if there's a power outage or a wiring issue, if a fuse trips, the Click PLC will maintain whatever outputs it had when the communication was lost. If you choose clear, it resets all of the outputs to a 0 level. So I'm going to leave that on hold. I feel like that's a safer option for most applications, and we need to define what addresses we're going to be reading and writing over Ethernet IP. So we're on the input tab again, and I'm going to click on start and then click on the 3 boxes there, and I'm going to go to the XD. So these are hexadecimal addresses for the different slots on the PLC. So this would be the built-in slot 1, this is the built-in slot 2, and this is the external slot 1 through external slot 8. So I'm going to start with address XD0, the internal slot 1, and then I'm going to end on XD0U. That's the internal slot 2. The reason I'm not using the third slot is because my third option slot, the first external slot, is outputs only. And then I'm going to do the same thing on the output tab. I'm going to leave the error condition on hold, and I'm going to set my start address. It's going to be YD this time. YD0 is the first onboard option slot, and then my end address is going to be YD1. That's the first external option slot. So a couple of things to take note of is we have 8 bytes output and 4 bytes input. I'm not sure I understand exactly why this is, but these are hexadecimal addresses. There are 16 bits per address, and for the inputs we're using two hexadecimal addresses, so a total of 4 bytes. And then on the output, we have a total of 3 hexadecimal addresses, and for some reason there's more, 8 bytes is more than 3 hexadecimal addresses. I believe there's a status bit for some or all of these outputs. So yeah, it's 8 bytes. When we set up the Ethernet IP settings in CODESYS, it's important that the input and output bytes match on both the CODESYS PLC and the Click PLC. So it's 4 inputs and 8 outputs. And then we'll go ahead and export this to an EDS file. That makes it a little bit easier to set up in CODESYS. And I'll just use that default name. And I've already done this. Sure, I'll go ahead and replace it. And then we can go ahead and close this. Now the last thing that we need to do, so the PLC is now configured to operate as an Ethernet IP field I/O device. There's not code running on the PLC doing anything. When an input goes high, it just goes high and is going to send that signal to the address that we defined back to the CODESYS soft PLC. And when the CODESYS PLC says change the state of an output, is just going to change the state of the output. The Click PLC is not going to be doing any processing. but we do need to have an end instruction. So I'm going to drag the end instruction to our first rung, and now that should be ready to go. So we'll go to connect. We need to upload this program, and I'm using a USB cable. If you're using a different cable, you could use a serial or Ethernet cable. If you're using Ethernet, you have to configure a static IP address on the programming computer that's in the same subnet as the IP address that we set up on the PLC. It's a lot easier, less configuration to just use the USB cable if you have one available. And so I'm going to connect. And I already have a program on this PLC. I don't want to read that program. I'm going to override it. So I'm going to choose don't read this. And now we are connected. This shows that we're in run mode. I'm going to go ahead and toggle the switch on the PLC to stop, and you can see the indicator change to stop. And now I'm going to write this project to the PLC. So it's compiling right now. There's no warnings or errors. It's going to ask me to save the project. I'll call this field IO. And then I should get the dialog to upload the project to the PLC. And I'm going to say all the default options here and OK. It's going to take a minute, and it's going to write that program to the PLC. When we get this transfer completed, we can say OK. And we're going to be done for now in the Click software. So now I'm in CODESYS. We need to program our soft PLC and configure it with some the Ethernet IP protocols to communicate with the Click PLC we set up. So I have a program already started. This is using the CODESYS Control Win V3 x64 PLC. That's the soft PLC that comes with the base installation of the CODESYS IDE programming package. And I have a simple program here that does some I/O. We'll look at that in a little bit. And I have a visualization set up that we can use for testing the I/O. The first thing we need to do is we need to add a Ethernet device. So we'll go to Add Device and add an Ethernet adapter. And I'll say Add Device. And then to that Ethernet adapter, I need to add an Ethernet IP scanner. And then we need to install the EDS file that we created in the Click software. So we'll go to Tools and Device Repository, and we'll go to Install. And here is the EDS file that I created. I've already installed this on the system, so I'm not going to install it a second time, but it's there. Once it's installed, if you go to Field Buses, Ethernet IP, Remote Adapter. So I have several already configured, but here is the Click C201 CPU-2. So we can come back here and right click on the Ethernet IP scanner and add a device and add the Click PLC. And then we can close that. So now if we open up the Click PLC, we need to do a little bit of configuration. The first thing, we need to configure the IP address. So that was on .13.10. And let's make sure our Ethernet adapter is on the right IP address also. Okay, so we're on the Ethernet, and let's go ahead and browse. So I'm going to be using, this is my IP, my Ethernet port on my PC. I have some others, Wi-Fi, and I have others, but yeah, I'm going to use this one, and it's set up with a static IP of 192.168.13.2, so it's on the same subnet as the PLC, so it'll be able to communicate.
If your Ethernet adapter isn't configured with this IP address, you'll need to go into the TCP/IP settings and assign a static IP address.
Now that we have the IP addresses configured, we need to set up the addressing on the Ethernet IP device. So if we go to the Assemblies tab, we can see here the EDS file gave us the input and output bytes. So the OT, if we go back to the Click PLC and go to our Ethernet IP setup, so we had 4 bytes, that's the inputs, and 8 bytes, that's the outputs. So this is the outputs, this is the inputs. But if we look here under our connection data, the number of bits does not match the number of bytes. Here, the OT, we have 16 bits, that's 2 bytes. We should have 8. And so this should be 8 times 8 should be 64 bits. And here we have 16 bits, and it should be 4 bytes. So we need to add some additional connections, and we can see that if we come in here to the Ethernet IP mapping and expand that. So we have our inputs and our outputs, and there's 16 bits, but only the first 8 bits are actually valid. So this would be for just slot 1 on the Click PLC. These would be the 8 inputs, and then the module I'm using only has 6 outputs. So these first 6 bits would be the 6 outputs on slot 1. None of these additional bits will control the outputs or inputs on slot 2 or the external module that I've added. So what we need to do is go into the assemblies and add some additional connections. So we'll click on add, and we'll say we want to add a 16-bit length. Let's see, we want these to be, look at the OT. So create a new connection that's an OT type, and we need a total of 8 bits. So I'll just add 4 and we'll see what happens. So that number changed to 10. Now that's going to be too high. It should be 8. So if I delete this one, now we're back to 8. And if we go to the Ethernet IP IO mapping, now we have these additional connections. So this would be, we're looking at the OT, that's slot 1. This is going to be slot 2, and then this is going to be slot 3. We need to add some additional connections for, those are the outputs, we need to add the inputs. So we go back to the assembly, and we want to add, choose the type, 16, and we only need to add, we need to add 1 more. So now we've got 4, 16, and 16. That's 2 bytes and 2 bytes is 4 bytes total. So we should be ready to go, because our 8 bytes and 4 bytes matches what we have here, 8 bytes there and 4 bytes. Okay. And if we go back to, oops. If we go back to our Ethernet IP mapping, I'm just going to collapse all of these just so we can see. So now we have, this would be the inputs on slot 1, inputs on slot 2, outputs on slot 1, outputs on slot 2, and then outputs on the auxiliary, the third module. For some reason, there's an extra connection on the outputs. I think that's a status byte, but we won't actually end up using anything on this connection, but it has to be there so that we have corresponding number of bytes on the inputs and outputs on both the Click PLC and here in the CODESYS configuration. Now in this this program that I have set up, I'm just turning the outputs on and off. Just a pretty simple program, but I've named each of the outputs 1 through 20, just so we can see what's going on there. I'm not using any of the inputs just because I don't have any of those physically wired, and I can, using the visualization, control the outputs. So I've named those variables output 1 or out 1, out 2, out 3, out 4. So I need to populate. So this would be slot 1. This would be out 1, out 2, out 3, and so on. I'm going to finish filling this out, and then by the magic of television, this will all be populated. Now I've got all of the outputs labeled. So this is slot 1. There's 6 outputs. Slot 2 has an additional 6 outputs. Slot 3 has 8 outputs. And these additional bits aren't really used, 6 through 15 and 6 through 15 here. And then also these bits are, I believe, just status bits, and we also won't be using those. So the last thing we need to do is we need to change the this update, always update variables. We need to change that to enabled. Use bus cycle task if not used in any task. And we need to do the same thing for the Ethernet IP scanner. We need to change that to run in the main task. And the Ethernet adapter we need to set to run in the main task also. So with that done, we should be able to go online, log in. I type my password correctly. So we have all green because my PLC was already running. You may need to start the PLC. But we have all green emblems here. If I go to the visualization, I can toggle this. And if we go into the I/O mapping, you can see which outputs are true based on what the button's done. So another thing we can do, where's it at? Here we go. We can do system monitor. Okay, so now you can see over here the indicator is showing what outputs are active on the on our what's now our field I/O module. So I've got 6, 7, 8, 9, 10, 11, and the number here is 11. When I press this again, now we have 12, and this one came on, and so 13, 14, 15, 16, 17. And this is happening in real time. As I click the button in the visualization, the lights on the physical Click PLC are coming on. If I click this one more time, they should all turn off, and we can cycle through again, turn on the outputs individually. So this is one way to use a low-cost Click PLC as a field I/O device for a CODESYS soft PLC. The CODESYS soft PLCs are more flexible than just a Click PLC. You can use structured text programming. You can use ladder logic. You can do other things. You have visualizations, including web visualizations, if you'd like. So it adds a lot of flexibility to a Click PLC for about the cost of another Click PLC. You get a lot of flexibility. The software license for CODESYS PLC is about $150, and that would be a license that allows for Ethernet IP connections, and that would give you all of the functionality that I've shown you here. All you need is a PC running the CODESYS runtime, and that can be a Linux operating system. I've got another video that shows how to install the Linux runtime, and here I've just shown how to work with the Windows-based soft PLC. But if you're not a lot of money, have the features and flexibility of the CODESYS operating system, or the CODESYS development system, being able to use structured text and ladder diagrams and sequential function charts and those other programming methods, but with the I/O capability and cost of a Click PLC.